We are going to find x-intercepts or solve. Those mean the same things. If you're told to solve a quadratic, it means find the x-intercepts. Or it can also be called find roots. You're finding the roots, you're solving, you're finding the x-intercept. It all means the same thing. And if you forget how to do that, you'll have your handy notes here to help you. And I forgot to take attendance. Let me take attendance real quick. Let's see. Ollie is here, Ben's here, Chloe, Anna, Elsa, Ethan, Griffin, Hannah, Lisa, Jake, Joy, Hirosh, Lauren, Lucy, Milo, Morgan, Nirta, Reese, Rita, Sanvi, Shannon, Cheyenne, Yashi. Okay, cool. So finding x-intercept, solving, finding roots. Let me give you an example of kind of the problems we're going to work out today. We'll call this example 1. Let's say we had y equals 6x squared plus 2x minus 28. Well, the first step to solving any quadratic is to always make it equal 0. So I'm going to make my y 0. And the reason we do that is because it's actually part of your answer. You've actually figured out half of the answer already. And I can show you over here. When we fill in the answer, we're going to say the x-intercepts are this ordered pair or this ordered pair. And in this case, we just made y 0. So we already know that there's going to be zeros there. All we have to figure out is the other value. When I see this quadratic, though, my heart drops a little bit because I know this could be a lot of work. There's a 6 in front of the x squared. And if you remember, when we factor those, you can't just factor them like we were on the homework. When you factor these, you have to multiply the a and the c together. And this is what I call like the long quadratic. These can get really long sometimes. But before you do that, you always stop and you look and you say, is there some number that I can divide into the 6, into the 2, and into the negative 28? You can divide them all by 2. So do that. It's going to make our numbers smaller. I'm going to pull the 2 outside. That means we're going to have 3x squared plus x minus 14. If you forget to do that, you can still get to your x-intercepts, but you're going to end up with a lot larger numbers on the way. Now we're going to work on factoring the 3x squared. And because of that 3, remember that we're not looking for factors of negative 14. In this case, when we look for factors, we have to multiply the 3 and the 14. So that would be 3 times 14 would be what, negative 42, I think. So we're actually looking for factors of negative 42 that are going to add to 1. So now I think, let's see, 1 and 42, 2 and 21, 3 and 14.
Wait, how would they add to 1?
None of those are, oh, so the 1 came from the b term. And so now I'm just trying to think through what would the factors be that add to 1? I can't think of it so far. Like,
Okay.
3 is not going to work. 4, you can't divide by 4. You can't divide by 5. Divide by 6, maybe. 6, yeah. Yeah, so negative 6 and positive 7. There we go. Those add to 1. This quadratic is really messy and has lots of steps to it. because we're still not ready to factor it. Remember, when you do this, your next step is to break apart the middle term into those factors we found. So it's going to look like this. I have 0 equals 2 parentheses 3x squared. Now I'm going to put the minus 6 next. Minus 6x plus 7x. If you combine those, you get back to 1 and the minus 14. I wish there was a shorter way to do this. There isn't. These just take a lot of work. Now, we look at the first set in there, the first 2 terms in the parentheses, and I think about something I can divide out of them. I think I can divide out a 3 and I can divide out an x. Now, when I do that, I'm going to end up with like 2 sets of parentheses. So I want to change one of them to a bracket. So my next step looks like this. 0 equals 2, and then I'm going to start using a bracket now because I'm going to have to use parentheses on the inside. I'm going to divide out a 3 and an x. And what I'm left with is an x, and then negative 6 divided by 3 is minus 2. So we went through factoring these kinds of polynomials before, but now we're seeing them show up in quadratics. I also want to factor the 7x minus 14, and I wanted to make an x minus 2 on the inside. So I'm thinking I divide out a 7. Yeah, that should work. So plus 7, and I'd be left with x minus 2. Close my parentheses, close my brackets. The very long journey to finding the x-intercepts. Maybe graphing would have been better. Probably not. I'd say both of them were about a lot of work on this one. So now we can tell the factors. I can tell the 3x plus 7 and the x minus 2. So for my next step, I don't need the brackets anymore. I can switch back to parentheses, and it would look like this. 0 equals 2 times 3x plus 7 times x minus 2. So that 2 that we factored out at the beginning, it just kind of sits out there in the front and follows along with all the math we're doing. Now what we have is we have 3 numbers are multiplying to make 0. The first number out here is a 2. This is 2 times this stuff. You can use inverse operations. You can undo multiplication by dividing by 2. Divide everything on the left by 2 and everything on the right. So what we get is 0 equals 3x plus 7 times x minus 2. So it's kind of nice. The 2 goes away because there is a 0 on the other side. Can you believe how long this problem is? Whew. Almost done. Oops, I went too far. I'll go back a little bit. There we go. Oh, I'll go back just a little bit more. So this minus 42, this is the big point of me showing you this problem today, is when you have something in front of the x squared, you have to multiply the a and the c when you do your factors. So that's how I got the negative 42, is I did negative 14 times 3. You always have to do that if there's something in front of the x squared. So now we're at the step where we can break these apart. Either the 0 is going to be the 3x plus 7, or the 0 is going to be the x minus 2.
Wait, I'm sorry, but
Yep.
for the a, like the a value times the c value, wouldn't it be like 6 times 28?
At the very beginning it was, but what we did is we saw that you could divide everything by 2, and by doing that, they made everything smaller.
So, but where did you get the 2 and the 14?
So I divided 6 by 2 and got the 3. I divided by 2 by 2 and got the 1. And then 28 divided by 2 would give me the 14. If you forget to do that at the beginning and you just multiplied the 6 times the negative 28, it would still work. And you'd still go through a lot of the same steps. Your numbers would just be a lot bigger. So to just back up a little bit, we took our equation, we said equal to 0. I saw that I could divide everything by 2, so I divided everything by 2. Then I looked for factors of negative 42, and I got that by multiplying the a and the c that add to 1. Then once we found those, you go through this method we learned before where you break apart the middle term and you factor out anything you can from the first part and anything you can from the second. So I pulled out a 3x and I pulled out a 7. And the whole reason we do that is so we can end up with that line right there, the factors that made that quadratic. This is about as long as complicated as they get. Because they are so long and complicated on your homework today, you're only going to have 2 problems that look like this. Okay. Actually, today I'm going to show you these really long ones. I'm also going to show you ones that are really short. Kind of the 2 extremes today. But we have to finish this one. We're not done yet. Down here, I can see that I'm going to add 2. So 1 x-intercept is that 2. The other one, it looks like it's going to end up maybe being like a decimal number. -7 minus 7. So negative 7 is 3x. And then when I divide by 3, let's see what the calculator gives us. I know it's going to be a negative number. 7 divided by 3 is 2.3 repeating. So our x-intercepts are at, it doesn't matter which one you put first, are at negative 2.3 repeating in 0 or 2, 0. That's where this parabola crosses the x-axis. It might be the beginning and end value. I took about half a piece of paper. Just curious, did any of you go jumping on a trampoline this weekend? Like at your house, at a friend's house? Yeah, nice this weekend. Anyone online? Morgan says her too. I took my daughters over to their cousin's house this weekend, and they have a big trampoline. And so I took Leah and Sasha out, and we were jumping on the trampoline. And you know what I realized? I think we talked about this before. Is when you jump on a trampoline, it's actually like a parabola. It could be like the coming down and then going back up, or that kind of sometimes might be more like a V shape sometimes, but it might be more the kind of going up in the air and coming back down. You have parabolas going on as you're jumping on a trampoline, and that got me to thinking. I wonder if anyone's ever used that for something interesting. And guess what I found? Let me show you a video. This is one place where you might find these quadratics in real life. And it has to deal with, and I'll help you out a little bit. I'll set it equal to 0 right from the beginning. We're going to say 0 equals 4x squared minus 27x minus 40. So when we start to find the x-intercepts, I see the 4, so I know that we're going to have a lot of work ahead of us. Is there anything I can divide into 4, 27, and 40? I don't think so. You can't divide them by 3, by 9, by 6, 4. Nope. So I'm thinking, you know what? It's already as simple as it can get. We're going to have to just start factoring it. So I'm going to be looking for factors of negative 160 because I multiplied the 40 and the 4 that add to negative 27. All right, thanks, Shannon, for letting me know. So, see factors of negative 160. You know what? Let's use the calculator. 1 and 160, no. 2 and 80, no. 3 and something. I don't think you can divide 160 by 3. Nope. Maybe you divide it by 4. You can do negative 40 and 4. No. What, 5? Ooh, yeah. Negative 5. No, positive 5 and negative 32. Those make 160 and they add to negative 27. Cheyenne, yes. We got the negative 160 by multiplying the 4 and the negative 40. And that's how you have to do these ones. When you see something in front for your A, you have to multiply them. Now we're going to break apart the negative 27x into those two factors we found. So I bring down my 0 equals 4x squared, and then I use my factors. This is going to be a plus 5x minus 32x and a minus 40. Like I said before, I wish there was a faster way to do these. There isn't. Now I look at the first two. Ooh, the 4 and the 5 don't really have any factors in common. So all I can take out is an x. This is going to be 0 equals x parentheses. There's my 4. There's my x that was left over. And then I have a 5 over there. And again, I want to make the things on the inside match. So for the second part here, I have lots of negatives and subtraction, but I would need addition. So I'm thinking I'm going to have to take out a negative. Otherwise, I won't get a plus 5 in the parentheses over here. And so then to make a 4, I'm probably going to pull out, what, an 8? I think I divide out a negative 8. Because that would give me, I think, 32 divided by 8 would be 4. So this is a 4x. Negative 40 divided by negative 8 is a 5. Good. No mistakes since the inside binomials match. Now we're at this nice step right here where we can say the factors are x minus 8 and 4x plus 5. Now we split. 0 is x minus 8, or 0 is 4x plus 5. On the left side, we just get 8. But then over on the other side, I have to subtract 5. So I get negative 5 is 4x, and then we divide by 4. Let's see, negative 5 divided by 4 is negative 1.25. So my x-intercepts are 8, 0, or negative 1.252. And again, order doesn't matter. Questions, concerns? Yeah. Welcome. All right, so now that we've gone over the long ones, why don't we do some short ones? These are like the longest you'll ever see. Let me show you some of the shortest you'll ever see. This is on your homework. You'll have two problems like what we just did. And then the other part of your homework will be like these other examples. Let's look at example 3. And I promise these will be shorter. So sometimes you might start off with a quadratic that's missing like the b term. So it might look like this. Y equals x squared minus 324. If you wanted to, you could do it the same way we did it before, but you're gonna have some big numbers there. You would look for factors of negative 324 that add to 0, and that would take a long time. Or think about this for a minute. The b term's missing. Because there's no b term, we can actually solve this with inverse operations. Let me show you what it would look like. I need to first set it equal to 0. We always do that first. Now I just need to get x by itself. So I'm going to add 324 to both sides. So I get 324 equals x squared. This means some number times itself makes 324. Or if we want to do inverse operations, there's a way to undo something when it has an exponent of 2. And that would be the square root symbol. Square root is the inverse or the opposite. Inverse means opposite. It's the inverse to x squared. So what I can do for my next step is I can actually take the square root of both sides. That'll get rid of the x squared. It'll undo it. So it'll look like this. I'm going to take the square root of x squared, and I'm going to take the square root of 324. So on the right side, because we have the root and the 2, those cancel, and you just have an x. And our calculator can tell us the square root of 324. The square root of 324 is 18. A lot of times you'll get a decimal here. Thankfully, we got a whole number. Have you guys learned about square roots before? I know we reviewed them at the beginning of the year, but usually you cover them earlier on in math. We're learning about square roots. When you first learn about square roots, or like this year when we were reviewing them at the beginning of the year, we're always told that it's going to be a whole number. It's not going to be a whole number. I mean, it's going to be a positive number, right? 18 times itself makes 324. However, usually you notice too that, hey, wouldn't negative 18 work? Like, isn't negative 18 times itself also 324? And usually you're told, well, just don't use the negative. It doesn't mean anything. In this case, it does. Because the x-intercepts are going to be at 18 and negative 18. So this is how we write it. The square root of 324 is both positive 18 and negative. So this has two x-intercepts. It's either negative 18, 0, or it's positive 18, 0. You have to use both when you do the square root. Square root is always plus or minus a number. Okay? Yeah, sorry, I told you lots of notes today. That's a lot shorter though than the other ones. Example 4. We could have a quadratic where maybe it's not set up to solve right away. Like maybe it looks like this. Negative 2 equals 4x squared minus 786. just like we talked about last time, if there's some numbers over on the left side, like away from the x squared and all the other things, move it over. So my first step here would actually be to add 2. That makes it equal to 0, but more importantly, it moves everything to the right side. So now we just have 4x squared minus 784. Now it looks like what it did before. It's in standard form. There's no b term. Because there's no b term, I know that I can do the square root step later on. So I'm going to add 784 as an inverse operation. So 784 is going to equal 4x squared. Now I divide everything by 4. And this is why it's useful to have a calculator. 784 divided by 4, 196. And then the inverse to something squared is the square root. So the square root of x squared and the square root of 196. That's how we get our x. And remember that square roots can be positive and negative. So it's plus or minus, I think it's 14. Yeah, plus or minus 14. So your x-intercepts are negative 14, 0, or positive 14, 0. Let's see. So we're learning the long form and the short form of quadratics. There's 2 more weird ones to show you. They're going to be in the short form. The 2 weird things you can see come up. But I'm out of room, so I have to go to a different piece of paper. Okay. We are on example 5. Let's say we had y equals x squared plus 81. Well, we know that we're going to be using that square root step. So we set it equal to 0. 0 equals x squared plus 81. Now I need to move the 81, so we're going to subtract. I get negative 81 is x squared. And then we do a square root of both sides. So what is the square root of negative 81? Be careful, it's a trick question. It's not going to be 9. Anybody know what it is? Morgan, you're trying to say something, you didn't come through.
No, I wasn't trying to say anything.
Okay. Shannon, you seem unsure. Here, let's try it in the calculator real quick. If I want to do the square root, it's above my x squared button down here. So you could say, I have to press second to get to it. I say the square root, and it puts in the symbol like that. I say the square root of negative 81. I get an error. It says non-real answer. Yeah, so you can't take the square root of a negative. Because it means something times itself made a negative number. You can't do that. So this means there's no x-intercepts. You try to take a square root of a negative, you can't. Yeah, so nope, can't have one. And it makes sense. If you think about the graph, it's opening up. It's not shifted, but it is moved up the y-axis up to 81. So it's not going to touch the x-axis. There's no x-intercepts. All right, one more weird one, and then I'll give you your homework. Number 6. Let's take 10 equals negative x squared plus 26. So I noticed that the 10's on the left side, the y is missing, but we already know how to handle these ones, so we should be good. I'm going to subtract 10 to get it over on the same side. That is 0 equals negative x squared plus 16. Be very careful with your positives and negatives, okay? They make a big difference. Now I have to move the 16 so I can do my square root. So I subtract 16. I get negative 16 is equal to negative x squared. And then a lot of algebra students stop here and they write, oh, no x-intercepts. We already talked about this. You can't take a square root of a negative. But no, you don't do that yet. You have to get rid of this negative in front of the x squared first. And so the way you get rid of the negative to cancel it is either divide or multiply by -1. So let's multiply everything by -1. And we get 16 equals x squared. And that you can take a square root of. So when you take the square root of both sides, you get plus or minus 4. So your x-intercepts, x-ints, are -4, 0, or 4, 0. Boy, lots of work today. Now you see the short form, you see the long form. You saw that you can use it to flip a car on a trampoline if you wanted to. If they were doing their math and they got something like this with no x-intercepts, that could mean a couple things. It could mean maybe the trampoline breaks and the car doesn't flip, or it could mean maybe the car breaks and the trampoline doesn't flip it. It means that there was like no like ending value, or maybe no beginning value. There's no beginning and end there. So something's wrong and they'd have to change it. So useful to know. Okay, homework. Your first set of homework will be like these ones where they're kind of shorter. And then when you get towards the end, there's going to be 2 problems that are long, and then 1 problem like they make a mistake and you have to fix it. For those of you in person, the homework's up there on the board. Okay. And let me post it in chat here too. And turn it on Schoology. All right, let's see, homework. We're going to be on page 551. 23 to 28, those are the short form. And then you're going to go to page 558. 17 and 23 will be longer. And then 36 is the one where you fix the mistake. You're going to start on that now, and I'll be here for questions. I do want to remind you of one more thing. I'm going to share my screen and show you this picture. When you're finding x-intercepts, you might have something like the red parabola where you get 2 solutions. That happens a lot. But you could also have something like the green parabola, like we did in our example, where there's no x-intercepts. That could happen. But there's also kind where it's like the blue, where there's only going to be 1 x-intercept. Watch for them. You might see them come up in the homework. 1 solutions, 2 solutions, and no solutions. Well, no x-intercepts.